Good morning, ma'am. Good morning, classmates. For my activity 1, I'm going to present the common laboratory apparatus. But before I will start, what is common laboratory apparatus? These are tools are mainly used to perform an experiment or take measurements and to collect data. So I have 5 examples of common laboratory apparatus. First is the glass funnels are for funneling liquids from one container to another or for filtering when equipped with filter paper. Second is the graduated cylinders are for measurement of an amount of liquid. The volume of liquid can be estimated to the nearest 0.1 ml with practice. Third is the hot plates can also be used as sources of heat when an open flame is not desirable. Fourth is pipettes, are used to dispense small quantities of liquids. And the last one is the ring stand with rings, are for holding pieces of glassware in place. So that's all for my activity 1. So now I'm going to proceed to my activity 2, which is the microscope parts and their functions. But before I will start, what is compound microscope? A compound microscope is a microscope that uses multiple lenses to enlarge the image of a sample. The total magnification is calculated by multiplying the magnification of the ocular lens by the magnification of the objective lens. Light is passed through the sample called transmitted light illumination. My objective is to provide useful magnification that allows minute specimens to be observed in great detail, thus exposing a hidden world of invisible objects that would otherwise remain unseen. So these are the parts of the microscope. First is the ocular lens or eyepiece, diopter adjustment, nosepiece, objective lens, stage clips, aperture, diaphragm, condenser, illuminator or light source, head, arm, mechanical stage, coarse adjustment, fine adjustment, stage controls, base, brightness adjustment, and light switch. So now I'm going to discuss to you their functions. So first is the eyepiece, also known as the ocular. This is the part used to look through the microscope. It's found at the top of the microscope. Its standard magnification is 10 times with an optional eyepiece having magnification from 5 times to 30 times. Second is the eyepiece tube. It is the eyepiece holder. It carries the eyepiece just above the objective lens. In some microscopes such as the binoculars, the eyepiece tube is flexible and can be rotated for maximum visualization for variance and distance. For monocular microscopes, they are non-flexible. Objective lenses. These are the major lenses used for specimen visualization. They have a magnification power of 40 times to 100 times. There are about 1 to 4 objective lenses placed on one microscope. In that some are rear facing and other face forward. Each lens has its own magnification power. Nose piece, also known as a revolving turret. It holds the objective lenses. It is movable, hence it can revolve the objective lenses depending on the magnification power of the lens. The adjustment knobs. These are knobs that are used to focus the microscope. There are 2 types of adjustment knobs. First is the fine adjustment knobs and the coarse adjustment knobs. Stage. This is the section in which the specimen is placed for viewing. They have stage clips hold the specimen slides in place. The most common stage is a mechanical stage, which allows the control of the slides by moving the slides using the mechanical knobs on the stage instead of moving it manually. Next is the aperture. This is a hole on the microscope stage through which the transmitted light from the source reaches the stage. Microscopic illuminator. This is the microscope's light source. Located at the base, it is used instead of a mirror. It captures light from an external source of a low voltage of about 100 volts. Condenser. These are lenses that are used to collect and focus light from the illuminator into the specimen. They are found under the stage next to the diaphragm of the microscope. They play a major role in ensuring clear, sharp images are produced with a high magnification of 400 times and above. The higher the magnification of the condenser, the more the image clarity. More sophisticated microscopes come with an AB condenser that has high magnification of about 1,000 times. Diaphragm. It is also known as the iris. It's found under the stage of the microscope and its primary role is to control the amount of light that reaches the specimen. It's an adjustable apparatus, hence controlling the light intensity and the size of the beam of light that gets to the specimen. For high-quality microscopes, the diaphragm comes attached with an AB condenser and combined they are able to control the light focus and light intensity that reaches the specimen. And we have the base and the arm. The base, it is the bottom of the microscope used for support, and the arm supports the tube and connects it to the base. Conclusion. I therefore conclude that microscope helps us a lot in science. It helps us see microorganisms that cannot be seen by your naked eye. It helps us identify diseases a human body have and also find cure for diseases. That's all for my activities. Thank you so much for listening.